Yeah, anytime. Look forward to having you in future meetups as well. Cool. Yeah, so that's it from Joshy. Now we have Sakun on screen. Joshy, I'm just going to exit you out. Oh, great, you did it already. Now we have Sakun joining us from Crust, as the CTO of Crust, and he's going to talk about how Crust plays with Substrate. I'll let you take it from here, Sakun.
Okay, thank you. And hi guys. I may share my screen right now. Okay, so hi, I'm Zikun from Crust Network, and I am very honored to be invited by Parity to be here to give you guys a brief introduction about Crust Network and how Crust plays Substrate. So before we start today's topic, please let me give you a brief introduction about myself. I am Zikun, CTO at Crust Network. So here is my background. Before I joined Crust, I studied at CCNT Labs and major in distributed system and cloud computing. And after that, I joined the Azure Kubernetes service team at Microsoft. So, and now I am a Substrate developer at Crust Network. Yeah, so that's all. Let's start today's topic. So today's topic will divide it into two parts. One is the overview of Crust protocol stack, and another is how Substrate empower us. What is Crust Network? Crust is a decentralized storage network, and it supports multiple file storage systems such as IPFS and fast DFS, and provide support for the application layer. So here is the Crust core protocol stack, and I will introduce the protocol stack and what each layer does. So generally, it's divided into three layers. The first layer is the off-chain layer, which called MPOW, meaningful proof of work. So this layer is responsible for validating and the storage status of node. And the second layer is the on-chain part layer, which contains the GPOS, which called guaranteed proof of stake, and the DSM, decentralized storage market module. As for the GPOS part, it derived from MPOS mechanism and responsible for the staking and the election functionalities. As for the DSM part, it is pretty much same as Filecoin. So it basically provides the storage market and the retrieval market so that people can put and get file from Crust Network. And the third layer is we call it application layer. So it is a packed SDK which can access with layer one interfaces. This layer is very similar to Polkadot.js. So it provides traditional cloud service interfaces based on Crust Network, like the storage, like the cloud storage services, like storage node election, the selection, and the replica redundancy or the disaster recovery. So with this, with our Crust SDK, the upper application or other parachains can provide more reliable and stable storage service. Okay, so next I will introduce how each layer works. So the first one is the MPOW. So this picture shows the basic flow of MPOW. It is too detailed, so I may go through the most important flow, which marked in light orange color, which is called file inspector. So the goal of file inspector is to regularly check whether the node storing files and generate a signed work report on chain. So how it works? Simply to say, it stores all the file root hashes inside the enclave, which the enclave is a trusted hardware runtime module inside your CPU. So, and it will regularly ask the outer file system to provide a specific file piece and check it inside enclave. So the whole process, the whole checking process is secured by enclave. So then it will generate a signed work report on chain, and the on-chain part will verify the work report's signature. So, so this is the Symfony flow of file inspector, the most part of MPOW. So the second part is the GPOS mechanism. So it is derived from MPOS in Polkadot. So the difference is in MPOS, we don't have stake quota for each validator, right? But in GPOS, we do have stake quota for each validator, which is decided by the storage resource of each validator. For example, let's say if you have 10 terabytes worth of storage space, and you can stake up to like 10,000 CRUs. So, but how do we get the storage space information of each validator? Okay, it is already included in the work report, which MPOW layer uploads onto chain. So in detail, this diagram shows the basic idea. So let's say the node 1, the storage will mapping to the stake limit, and it decides how many your stakes and your guaranteed stakes is affected. So only the affected part can give you the staking reward in each era. So, okay, the next is the DSM part. Oh, sorry, I maybe skip this. Okay, so next is the DSM part, decentralized storage market part. So this picture shows the basic working flow of DSM. So the on-chain part will record the storage order comes from client. So and it works like very similar to a smart contract. So after this storage order being placed, or the smart contract being placed, the off-chain part will handle the file transferring and the validation process. Okay, okay. As you all know, we designs and implements Crust by Substrate, and all the functionalities I just mentioned are empowered by Substrate. So next, I'm going to introduce how Crust plays Substrate. So first, also is the GPOS mechanism. So the target of GPOS mechanism is to add the staking quota based on storage resource into the MPOS mechanism. So how do we do this? We change 6 parts of MPOS mechanism. First of all, we adding the stake limit for validator to calculate the ERA stakers, which is used to calculate the staking reward of validators and its guarantors. Okay, and the second, we keep all the bond and validator behaviors in staking module. And third, we change nominate operation with specific amount. That means we allow each guarantor can choose who and how many he or she wants to vote. Okay, so fourth, we change the fragment election algorithm, which is in the Kusama and Polkadot, into our top-down random election algorithm. And last, we separate the reward into the authoring reward and the staking reward. The authoring reward, which only the elected validator can get, and the staking reward, which both the validators and the candidates can get. Okay, this is the whole solution and the main changes based on the MPOS mechanism. So next is how we design the MPOW's upgrade. But first of all, is a big question is why do we need it? So actually, Substrate already has a completely forkless upgrade mechanism based on WASM code, right? But we still need to design our own MPOW's upgrade mechanism. But why? Because because the scenario is different. So the MPOW, first of all, the MPOW module is off-chain, and so it cannot be covered by the Substrate on-chain upgrade. Okay, and the second is MPOW is mostly in TE enclave, and which in TE enclave, and which is totally separated from each other. That means TE enclave cannot trust each other. Okay, and we have 3 time to prepping our upgrade. So the first is we want to fix a big security bug, right? And the second is we want to upgrade our enclave, and last is we want to improve our performance. So the target is quite simple. Is I'll name the old version of MPOW code as old A, and the new version of code as new B. So the target is to migrate the old A storage status to new B. Then the new B will inspect the storage status and report the works in the future. Okay, that means B will replace A as a new MPOW module. Okay, but However, like I said, the enclave cannot trust each other by its own. So the difficulty is quite clear. The first is, the newbie cannot trust the old A. That is because the encrypted enclave runtime are separated. So they cannot trust each other. They cannot recognize with each other. And the second is, it is hard to distribute the execution file, like the Ethereum's difficulty bomb upgrade, right? So before we start our AB upgrade solution, we can say the focus upgrade in Substrate, and it gives us 2 points to think about our problems. One is the WASM code can be validated by every node, okay? And the second is it is very easy to distribute the execution runtime by just call the system.set code from extrinsic and can through it and can pass to every node. So this is very easy. So these 2 points gives us inspired us to design our AB upgrade. So basically we take this the focus upgrade 2 points into our AB upgrade mechanism. So the first is we use the on-chain enclave code to let the new B to trust old A indirectly. So it's pretty much similar to set the WASM code with Substrate. And second, we use the on-chain enclave code changing as upgrade signal, which means the old A can monitor the MPOW's upgrade status on chain and upgrade into new B automatically by pulling the Docker image or the binary from GitHub. And this distribution, this distributed way is very like the focus upgrade distribution behavior in Substrate. So basically, this is the whole thinking process and solution about AB upgrade. Okay, so sorry. Sorry about that. Okay. Okay, so let's continue. Next I will share how do we use the off-chain worker, another big feature in Substrate to handle the massive storage orders. So the target is all about the performance. The first is we want to reduce the space. So we want to reduce the total amount of storage orders on chain, right? Another is we want to handle the storage order updating on reporting work report at each era. So the second one is we want to reduce the handling time. So let me quickly explain this because I skipped the process flow in MPOW part. So the work report includes the file storage information of each node, right? Which we need to use this information to update corresponding storage order status. And this may take lots of time to handle the update because the data structure is reversed index hash map. So if we want to handle the on-chain update, it may vary like to exceed the max block time. So the solution is quite straightforward with the off-chain worker. So from a space point of view, we design our off-chain storage order system to cache the storage orders. Okay, so it will be packed into one big storage order on chain. When cached, the storage orders get stacked up to like 4 GB in our current test net. So from a time point of view, we put the order updating off chain. So we use the off chain worker to record the order updating status. This can be running during a whole era. Actually, the second task is a very typical long running task, like in Substrate's staking module. We're using the off-chain worker to handle the off-chain fragment election algorithm. So okay, so that's all my sharings. Thanks everyone, and I say if you have any questions. Paper or tutorial explain. Okay. Okay. The first question is Okay, so the first question maybe ask for Josh. The second question, okay, also ask Josh. Okay, the third question is how fast to get and put. Okay, I may switch to this. The first question is how fast to get and put file by using Crust network. The second question is how to regularly check files and how fast it be. And the third question is differences between Crust and Filecoin. Okay, maybe I will start from the last question. Is maybe most of you very care about the last question. So the differences between Crust and Filecoin. Okay, so there is no doubt that Filecoin is the big brother in decentralized storage area. As a newcomer, Crust actually has two big differences with Filecoin. The first and the biggest one is in technology. We are using a totally different idea to solve the same problem. And Filecoin use the POST, which called proof of space-time, and the POR, proof of replica consensus as its fundamental technology. Okay, and but which contains a very dedicated zk-SNARK proof algorithm to check file and the VDF-based authoring algorithm. They are both pretty cool and edge. But from its testing data, those algorithms needs huge computing costs and big storage cache costs, like sending sector data, which is 32 gigabytes. It needs 4 hours in the Filecoin officially recommended hardware with GPU and big memory. And also, it needs more than 512 gigabytes cache when it's under the sending process. So comparing with Crust, we import the TEE technology to design our, like I mentioned, the MPOW mechanism. So the proof process of MPOW could be super fast and effective because all the proof happens locally. So from our testnet testing data, we only need 8 seconds to sell 1 gigabytes data, which means if we sell 32 gigabytes data, we only need like 4.3 minutes, which is super fast. And this is 55 times than Filecoin does. So that in Crust network, we do not need a huge memory and super fast GPU. Even the PC contains, if you contains the Intel SGX module, can become to our nodes. Okay. Second is the second difference between Crust and Filecoin is in incentive layer. The Filecoin actually is a POW based chain, which simply to say is who has bigger storage volume, who gets the money. Okay, but Crust actually is a POS, proof of stake based chain, because your storage volume will reflecting into the stake limit. Like okay, I will show again this picture. Wait a second. Like this diagram shows you that your storage volume only mapping or reflecting into the stake limit, and which determine your staking reward. By the way, this mechanism is derived from the NPOS in Polkadot. Due to that, this mechanism is also void of the centralized attack in a POS. Okay, the second question is how fast to get and put files by using Crust network. Okay, regardless of your network issue, getting and putting file only takes you, like I said, 8 seconds extra, because essentially it is a sending and unsending process. Okay, and any questions? So how to regularly check files and how fast it be? Okay, this is a great question, and like I mentioned before, this is two questions. And first is how to regularly check files and how regularly check files. In this graph, the flow marked in light orange. So we use the enclave inside the MPOW module will record all the files, Merkle root hashes, and it will regularly ask the outer file system to give you the specific file piece and check it inside the enclave module. So the checking result will be reported onto chain. So as for the second question is how fast it be. In our testnet, we set the sampling rate is 2%, and the file piece random check rate is 0.5 per thousand. So that means the 192 terabytes data will need about like 30 minutes, which means if you want to, if the node, if the MPOW fully checked the 192 terabytes storage volume, it needs like 25 hours. Yes. Okay. Okay, seems like there is no questions. Okay. So thank you guys.
Yeah, thank you, Sikon. That was a great presentation. It was great having you here, and thank you for all your questions and everybody asking them and the great answers you've given. Thank you so much.
Thank you. Bye.
Bye. Great. I hope you all enjoyed today's meetup. We have this meetup every month, so we'll have another one in September, so be sure to check that out. We have a few regular events going on every Tuesday. We have our Substrate seminar, as mentioned before, and I'm just going to quickly share some research sources here on the chat so you can continue to learn Substrate and follow our updates, and make sure to sign up for our newsletter. There you'll find all like new updates of like what's happening with Substrate and also all events that we are hosting and also participating in. Thank you so much for joining us today, and we look forward to seeing you at our future meetups. Have a great weekend, everyone. Ciao.